Good afternoon. I'm Steve Trampert.
And I'm Morgan Zinko, and we are both students at the University of Rochester Hajem School of Engineering. Stephen here is a member of the prestigious Tau Beta Pi Engineering Honor Society at the U of R.
And tutoring chair as well there.
Now, one of the primary missions of Tau Beta Pi is to help students get into engineering majors and to succeed in them. And the way we do that at the University of Rochester is we require every one of our members to participate in 1 hour of one-on-one tutoring per week. It means that as tutoring chair, my job is to receive emails from students all over the Hajem School asking for help in different subjects, and then to connect them with students in our group, Tau Beta Pi, who can tutor them once a week for an hour. Now, that's a very annoying process. It involves consulting this massive spreadsheet and assembling another massive spreadsheet filled with students. This spreadsheet here is our master spreadsheet of tutors. So these are all the members of Tau Beta Pi right now and the different courses they feel comfortable tutoring for. And then we'll also have a spreadsheet, something like this, but much longer, which is all the students. Now, I had to make up a new spreadsheet in the interest of privacy so that we didn't compromise any student identities, but this is what it might look like in the first week or two. We have about this many students. By the end of the semester, it's gotten much longer to the point where we actually can't satisfy the demand for tutors, even with all these tutors, since our service is free and since it is quite helpful. Now, the reason why this takes so long to do by hand is because there's a lot of different factors you have to take into account. The most annoying of which is that there are some courses which are kind of very high priority. For example, in the first semester, we always run out of Chem 131 tutors because everyone takes the course and there are very few people who like to tutor for it. So if we have a tutor who can tutor for Chem 131, we want to make sure that we only assign them for Chem 131. Maybe they can also tutor for CSC 160, for example. We don't want to assign them to tutor for CSC 160 because we're wasting them when they could be working for CHM 131. So whenever you get a new student who wants to be paired with a tutor, you have to consider stuff like this. You also have to take into account the Dean's Office provides us with a list of students who require additional assistance, who get a higher priority in our queue for getting matched up. All this means that it takes a very long time to match students by hand with this crazy spreadsheet method we're using right now. So I've designed a little Matlab tool that makes the whole thing go much faster. And to give you an understanding of just how difficult this problem is, even for Matlab, it takes it 5 minutes to find an optimal solution. So let me walk you through how it works. You start the program, and the first thing it does is it sucks in these 3 Excel spreadsheets. One is a master list of all the tutors we have. One is a list of the students that have asked for help, and this includes also students that are already paired. It filters those out to begin with. And it also includes this spreadsheet here, which is a list of the different courses that are very important this semester and a weight assigned to each depending on how important they are. It takes all that and creates this matrix down here, which I've expressed manually. This left-hand column is all the students who are currently unassigned to tutors who need pairs. To the right of this left-hand column, and by the way, these numbers, they represent the row number of the student in the spreadsheet. To the right are a list of all the tutors that can tutor in that subject. For example, student 3 here actually needs help with CSC 160. I just know that off the top of my head. Each of these tutors, each of these row numbers, which represents a tutor, can tutor CSC 160. Now, the hard part is that there are so many permutations that you can choose, because you just need to choose basically one column here. And you can pick any number from any of these rows that you want for each of those column members. There actually ends up being, in this case, over about 165,000 different permutations. What I do is I have Matlab run through every single one of those, and it takes it some time, but it does it, and it's worth it for what it does, because I have it score each of these depending on how well, first based on how many priority courses those tutors can handle, and you want basically to assign the least important tutors you can, so that's how that works, and also to come up with a permutation that allows you to have as many of the students that have requested tutors to receive tutors as possible. So Matlab calculates those scores and then sorts the matrix based on that and picks out the one that has the lowest scores on both counts and gives you an output in plain English here. And the tutoring chair can very easily read this and get everyone paired.
Now, I say that my program steps through every permutation, but in reality it actually does far fewer than that, and that's by design. I actually spent a lot of time trying to improve the efficiency of my algorithm by not actually permuting out any permutations that would be impossible to assign. For example, permutations where a whole bunch of tutors are assigned to students where they don't actually know the course the student needs to learn. And by doing that, I make it so that it's actually a computable problem, because otherwise Matlab has to step through so many permutations that it takes hours to go through a single pairing.
So there's a reason why we call this an engine. That's because we see it as a great platform to build on.
But not only at Tau Beta Pi, but also at a variety of organizations, such as Big Brother, Little Brother programs, any kind of organization where mentors are paired with students.
In addition, we call it an engine because we're going to build on it. Now, in particular, we're going to add a GUI front end to this using MATLAB itself, and also use MATLAB's send mail function to actually design this thing so that in addition to pairing the students, the person operating the software can hit a prompt and it will automatically send out all the emails to everyone who's been paired, to the tutor and the students, to notify them that they're now paired together and encourage them to meet up, which is the other half of this process that becomes very time consuming.
This notification system will actually increase efficiency by a great amount and will help these programs, whether new or old, run far more smoothly than they have in the past. Now, thank you for listening to our presentation and watching us work with our code. Thank you very much.
Have a good day.